You put it wherever you want. What is this?
Summaries.
Okay, there's just summaries. So everyone should have their literature review printed. Is that correct? Fuck, where did I put this? Sorry, the recording that will just be my face really close for a long time. Oh, here it is. Okay, there we go. All right. So let's go to what the rest of the class looks like. Thank you to anyone who has already filled out the SOTI. And if you didn't have time to fill out the SOTI, you see that I make a fake SOTI and I just put it up forever. So you can always give me feedback, including after the SOTIs are done. Some of the feedback that I got for Astro already, which is great because now I can get the feedback right now, is that seems highly disorganized, right? And I can accept that as a valid criticism. Sometimes, you know, this schedule can be a little difficult to manage. So I know how we're going to do this next time, but you won't be live for that. So, or around for that. You will be alive. It's only 2 years. It's only 2 years. It's only 2 years. I meant around. So let's just talk a little bit about expectations, because I've even heard in this last week people who thought maybe they had to do less things than they thought they did. So let's revisit our expectations. You should have written summaries that you've compiled throughout the entire semester. I will want to see all of your written summaries, not in the original version with all the feedback that I got, just the final versions, right? So they'll represent your best abilities, right? So if you got feedback that said, you know, fix this, and then you decided, well, I don't have time to, that's perfectly okay. At least show me that you did it, right? So that's all the summaries. That's one component. That, when I say summaries, that includes if you decided to apply for the GRFP, any personal statements you might have written, if you decided to apply for a job or to write a CV, anything that you wrote for this class, include. And that'll just be one pile of material. Okay. On top of that pile of material, you're going to add the literature review. That literature review has no page limit or minimum, but it is required to have these components as we discussed in class, right? Those components. Title, that's the easiest one. Your name, that's the easiest one, okay? Abstract, intro, discussion, summary, and references. Yeah.
Just like the bottom paragraph, like discussion,
Mhm.
how long should that be? Or not exactly, like roughly?
As long as it needs to be. So let's say you're discussing a topic, right? What is the point of the literature review? It's to demonstrate what you learn from all of these papers, okay? I'm not going to give you a requirement of 3 paragraphs or 10 paragraphs or 15 paragraphs, right? If you can demonstrate to me everything you learned. If your discussion is 1 paragraph and your introduction is 1 paragraph and your summary is 1 paragraph and your entire paper is 3 paragraphs, I would probably say that doesn't cover it. But that doesn't cover it from a different perspective, right? Which is this one here. 12 citations or greater relevant to the material at hand, right? Also demonstrating that multiple points of reference were used, right? Showing that at least 6 papers were read. So if you say to me, okay, I went through this process, I started writing, and I wrote everything I know. Great. That's what I want you to do. And I'll see that because I'll see multiple points of view. I'll see a discussion in your discussion where I asked for it, right? Is it going to be the perfect, best piece of writing that's ever been seen? No, that's not the expectation, right? The expectation is that we're learning how to communicate scientifically. We are learning how to do a literature review. This will be your first literature review. So will your literature review be perfect? No. Maybe for perfectionists it will. Okay. Will your topic sentences be perfect? Yes. That is the only and most important thing that I want you to take away from this. Every one of your summaries, every one of your written statements are all going to be including good scientific writing. So maybe this class should be called topic sentence writing. That's not as fun. Okay, right? That's the number one thing that we agreed upon. Because if I can read your entire paper or your summary with some good, strong topic sentences, that's good writing, right? Okay. And then there's these other ones too, right? How it's structured, doesn't seem like an AI wrote it. That's going to be pretty important, right? Seems like an AI wrote it. That's going to be not as high a grade as you want, right? Okay. That makes sense? Okay, so that's your literature review. And then you have a project you're working on in Python Notebook. Yeah.
I saw that.
Okay. So you have that project and you'll email me the project file. That will be an IPYNB file. And it'll have notes. Ideally, it'll have comments, not comments, right? And that's it. That's your whole grade. Do you want feedback on that before you get your final grade? Like, do you want me to send you an individual email that says, I think you have an A in this, a B in this, a C in this? Everyone want that, or just a few people? Or you just don't care? Send it. Okay. All right. I'll send a few people. Yeah. Okay. For sure. Okay. Anything else? Okay. So we built this rubric together. So that means, legally speaking, you all agreed to it. Oh, damn. Right? You hate that you agreed to it. But that means that it's existed this whole time, and we can work around it. Now, sometimes I have done this, and it's a very, very bad habit. So let's say I'm giving a talk on a Wednesday. When do I write my talk? Tuesday night into Wednesday morning. Yeah, that's correct. That's a really, really bad habit. I can get away with it because I've been doing it for more than a decade, right? And I know exactly what I'm talking about. I'm mostly doing my own stuff, right? And if there's something that I need to bullshit on a slide, I'll just talk longer on that slide than I would normally. And you can hear me, right? I'll just ramble, right? Nothing important comes out. It's like a large language model, but it's my mouth. Okay. Can I get away with writing a paper the night before? No. Are you going to try to? Probably. So today what we're going to do is I have you legally until like 7:15. Oh, Jesus. So that means that I will be here working with any and all of you on getting whatever material you want up to the level that you think it should get to. You could look at me right now and say, my best use of this time is to go and prepare for something else that I think I'm going to fail. And I would say, listen, I understand that, right? You have to, sort of pay attention to your own time. But what I'd like to do right now is for you to take however far you've gotten in your literature review, whatever form it's in, I want a printed version of that you're going to pass to a colleague, and they're going to use this rubric to interpret, just like I will use this rubric to interpret. And they're going to give you feedback. And then if you want, you can hand it to me, and I'll give you the same type of feedback, right? Feedback on your feedback, yeah.
So when we turn this in, or what date is it?
I think probably like this Friday.
It's Friday.
No, let's do it next Thursday.
So, like, email us then, like, what you want it afterwards. I wanted to, I can see that.
So you can turn it in at any time, and I told you this from the very beginning. Okay, so right now you could give me a version, and I will strongly recommend that this happen. You get some peer review on it, and then you walk it over to me, and I'll give you feedback. Right? And that's only going to make you a better writer. If you want to turn it in this Friday as like a pseudo first draft and you want feedback on it, I'll give you feedback on it. Does that make sense? Yeah, the stack that I require for you will be on Thursday. And when I get that stack, I won't be able to ask you for any changes, but everything you give to me up until then will count as changeable. Or if you give something to me on Wednesday and you tell me that you're going to give it to me on Wednesday, if you give me a giant stack on Wednesday and expect feedback from Thursday, that's going to be a little rude. But if you say, hey, listen, there's just one more summary. Do you mind having a look at this? I'll bring it in, Wednesday afternoon. I'll fix it and I'll hand it right back to you, right? Because it's a writing intensive class. So you have to write. Okay. Is that reasonable? Everyone agrees to the terms and conditions? Okay, so let's write the terms and conditions very specifically. Final project plus lit review plus all summaries. And let's do Thursday, close of business. You guys know what close of business means? Let's write that again. 5 p.m. on what is that? 12/14? There's never been check-ins for this class. For Phys 4400, yeah, you'll need to do check-ins. Or you can take the exam if you want. The exam would be in the finals time. There's some pre-dictated finals time that I'm required to give you a final in, which is why I hate using that time period. You can turn it in whenever it's done. You could turn it in Monday if you're finished. Don't roll your eyes at me.
But like if you're not here, they come at 10.
Then you put it in my mailbox. Yeah. Yeah, there's always someone in the office. Worst comes to worst, there's a big gray pail outside of my office. That's a shredder. I'm just kidding. But that would be funny though, right? You're like, oh, I put it in your mailbox. It's gone forever. Okay, but does that make sense? Yeah. And I'll be around all week, probably doing people's check-ins for Phys 4400. So my expectation is that I'll probably have 11 check-ins on Thursday. I don't think anyone will want to do it earlier, but I'm going to give them the opportunity. So I'll be around. We have the opportunity to do observing tonight. If people want to do that, the weather looks fine-ish. If you want to, or we're going to do it tomorrow for an open house if it's not too cloudy. Let's look at the weather for tomorrow. That is on Thursday. Let's not say that. Let me look here. So, yeah, it looks fairly clear tomorrow and Wednesday. Wait, hold on. This is supposed to update. This is gone. So this is Thursday. So this is Tuesday and this is Wednesday. Yeah, clear, mostly clear, partly cloudy. Thursday looks like it might have the worst clouds, but it's not bad. If you're saying to yourself, well, I have all my data, that's okay, Jim. That's how badly it's going? Okay. Okay. Any other questions about the program? programmatic questions. Okay. Good. Oh yeah, if you want to, there's can roast me on here too. Well, look at how many reviews. Only six. And people only said I'm a 3.6 level difficulty. You gotta get those numbers up. Those are rookie numbers. Okay. So yeah, you can give feedback. Someone gave feedback, I guess, this month. I don't know. Someone just rated me. They just rate you. Nothing you can do about it. Online savvy. Caring. Yeah, everyone says lots of homework, lots of homework. Amazing lectures. No, that's not one. Get ready to read. That's one of my favorites. I read a shit ton. This fucker likes reading. Okay. And then here's the anonymous feedback form. And yeah, I really do appreciate when people fill this out. You'll notice that there is no information about what is said. Right? I don't ask. And even when you look at the individual, it won't have any identifying information. So don't feel like if you tear me on there, you tear me on rate my professor, I'm not gonna like impact your grade. My skin is not that thin. That make sense? Okay. You can find this one in the course modules. I added it here. I called it fake SOTI for both of them. And this one I forget how to find, but it's like ratemyprofessor.com. I forget how to find me. It's weird. You have to like find Sarah first. Oh, sorry, Dr. Chloe first. And then it's like linked at the bottom here. You find like other ones. Like look at Joseph. Joseph's great. Why don't we take a class from Joseph? And he's easier. Oh my God. Caring, respected. You want to see what PK has? Let's go. All right. That's not bad. Not bad at all. Tough grader. All right, who do you want next?
Dr. K. Oh.
That's rough. But let's be clear here, right? You have to look at the distribution. So you have to go into the classes and you have to see what kind of classes this was, right? I don't know what this is. And look, this is Phys 224. Yeah, I mean, look at these. This is a decade ago, right? So I don't know that this really reflects everything. Possibly, yeah. There you go. Well, he doesn't have one here. He's gotta port it over. Yeah, this is where we got him from. We stole him from Colorado. Yeah, it's a finance. I don't think this is the right Youngman Chem. Now I'm really curious. This is the finance department. Yeah, that's really fascinating. But only this person would take it again. So this person didn't respond to that prompt. Right? It's not a requirement to ask whether or not you would take it again. What is my take it again? Like, I don't even come up when you search. See? I have to do Oop, that's not right. That's how I find myself. Okay, everyone would take it in. It's not bad. Of the 6 people, it's not that many people. So speaking of taking it again, we'll be doing Math Methods 2 next semester. Some of you are taking it. Some of you are too scared to take it. That's okay. The things that we'll learn in Math Methods 2 are using tensors, I will show you what complex analysis is, but I hate complex analysis and I think it's really boring and useless now that we have computers. So we won't go into it. If you really want to learn complex analysis, let me know. But I think honestly, it's been replaced, you know? It's like when we used to learn how to use a slide rule, which you probably don't know what that is, but do people know what a slide rule is? Yeah? Okay. Okay, good. Some people.
Learn about
What? You both spoke at the same time. Yeah, that might be true. What was your question back?
this stuff like
For math methods too?
Yeah.
It would be like describing how space-time curves and creates black holes. Yeah, so that would be the applications of tensors. So you've already seen applications of tensors and you haven't even noticed it. So for example, we did this in the context of fluid dynamics. And we've done it with your E&M tensor. The TXX is a tensor, right? So oh, that's my hand. Utilize whatever the fuck that was. Utilizing those in the context of mathematical methods, right? Mathematical methods is teaching you the math you need for physics. So I will just show you a third way of doing tensors, which is special and general relativity. And then we will primarily do data analysis and probability. And so to sort of highlight the fun of probability, I would like to ask you the following question that I asked Reed today. Okay. So he told me, he reported that for something like Boulder, Colorado, which has a very low acceptance rate for its graduate program, something like 400 applicants apply and 20 of them are accepted. So what is the percentage, the likelihood that you will get accepted at Colorado? 5%. Wow, off the top of your head, that's very good. That's a lot better than me. I had to type that into my computer. Okay, so now let's ask you the hard question. So the likelihood. Can you see that okay? Can you see that okay? Okay. Of grad school. Is 5%. Can you have a likelihood over 100? No, you cannot, ever. Not by the definition of Bayesian statistics. No interpretation of statistics allows for a number greater than 1. Something either happened or didn't, right? That's the idea. Okay. So the likelihood of going to grad school is 5%. So what's the likelihood of not going to grad school? Oh, you already know. Okay. So what's the likelihood that if you apply to 5 graduate schools, you'll get into one of them? What? How do you figure that out? You times that by 5? Interesting. Let me ask you a different question. And this is the way that I will basically be introducing all of statistics. We'll always bring it back to coin flips. Okay, that's the easiest things for individuals to understand. I even made a TikTok about how to understand your likelihood of winning the lottery. And that'll be, I made it. I'll make a TikTok like once a year. And they're really stupid. So here's how we want to think about it. Here's how we want to think about all statistics. We want to think about them as something that we can understand, right? I don't really know what 75% means off the top of my head. But if I think about it in the context of coins, let's think just of one coin first. Okay, so if I have one coin, there are 2 sides. One has an H on it and one has a T on it, right? Everyone knows coins? Okay, so if I flip it, there are 2 possible outcomes. So I always write outcome at the bottom and the number of ways to make the outcome I want. The number of ways to get the one I want here. So what's the probability? Let's say I want heads, that I get a heads. 1/2. Okay, so probabilities are usually shown as a fraction and then turned into a decimal. So in fact, we did that over here. We said we want to be one of the 20 people out of the 400 possible people, right? So of course, not every school is gonna have this small an admissions rate, but this would be the worst case scenario, right? Everyone that you apply to is either Boulder or Harvard or something like that, right? Okay, so let's think about this one. Let's say I have 2 coins. What's the probability if I flip 2 coins that I will get at least 1 head? What? Half. Let's do hands. Greater or smaller than a half? Which one? He just read this again. Okay, greater than a half? Smaller than a half? Doesn't like to answer the questions. What do you got?
We just multiply 1/2 times 1/2.
That you'll get at least 1 head. What's that? What are the possible outcomes? Let's figure out the outcomes. I have HT. I have TH.
Yeah.
I have HH. And I have TT. Okay, so how many outcomes do I have? What? 4 outcomes possible, and 3 of them contain what I want. So the probability of getting 1 head is constructed like that. And that is neither 25 times 25, or sorry, 1/2 times 1/2. Right? But it is the opposite of a different way of looking. So if you say, well, I only want this one, right, then this number is 1 minus only getting this one. Right? You see that yet? Okay, let's say I want 2 heads or 2 tails. There's only one way to do that. So the probability of exactly getting heads, heads, or tails, tails is 25%.
I'm still confused. Why do you say 1 minus that?
Right. So this can happen 75% of the time. And this can happen 25% of the time. And they have to sum too, because something always happens. Okay, so we can do statistics either by figuring them out specifically, or by figuring out what is not going to happen and subtracting it from 1. And this is how we'll do statistics. This is how we'll understand the entire world. So let me ask you a different question. Go back to the lottery, okay? It's Mega Billions time and it's Christmas and someone's got to pay for this goddamn presents, right? Okay, so the odds are 1 in 200 million. Likely or not likely? Pretty likely. Nope. Okay. So if I flip 2 coins, I just described, the likelihood of getting 2 coins in it, like heads or tails. Let's say I want to only pick heads. 2 coins would be 25%. 1 in 4 is the likelihood of H, H, right? Yeah.
So if I played 200 million times one go around, then I'll get it for sure.
This is a very interesting question. Let's probe into that, because you're gonna be deeply, deeply disappointed. Okay, so let's look at this number here. We're gonna think about just grad school. Right, 5% chance of going to grad school. So what is the probability if you apply to 5 grad schools that you don't get into any of them? How would I construct this? Do you want to do the outcomes? Yeah, I don't want to draw 400 dots. That sounds fucked, right? So let's use this technique here. Let's use the opposite. We'll say that the likelihood that I don't get into any grad schools will be the opposite of this, which is 0.95. And it'll be independent. So each one, 0.95 times 0.95 times 0.95 times 0.95 times 0.95. Okay. I'm not going to get into any of them. Okay. And I'm going to multiply all of those, and then I'll do 1 minus m. So let me show you. Is this confusing yet, or did you get it? Yeah. I know that this is not what we're supposed to be doing, but it's still fun. And you like math, right? Oh, what? Okay. So what's the probability that you get into grad school? 5%. What's the probability that you don't get into grad school? So it's 1 minus 0.5. Right? Good. Okay. So the probability that you don't get into grad school is 95%. What's the probability that if you apply to 2 grad schools that you'll get in? Just one. What's that?
495 times 425.
Let's write this same framework again. Okay, let's write the same framework again. Ready? Here's getting into grad school. Here's not getting into grad school. Right? Let's imagine it's 50-50. Right? Let's imagine it's 50-50. Okay. It's a coin. Everything can be understood back in terms of coin flips, right? Okay, so this is one school. If I have 2 schools, how do I combine their probabilities? You have to enumerate them first, right? In, not in, not in, not in, not in. So if you want to see, well, I get into one of these schools and all of these ones, then the probability that I don't get in is 1 in 4. Right? And let's do that with 3, and you'll see the pattern. In, not in, not in, not in. Okay. In, not in. Oh shit, I didn't backwards. Not in, not in, not in, not in, in. See if I did that. 1, 2, 3, 4, 5, 6, 7, 8. I'm missing one. Am I? No, I'm not missing one.
Yeah, you need to do in, not in. Wait a second.
In, not in. So there's 8 outcomes. And only one that I don't want. So I get into one in every other one of them. But now it's 1 in 8. Right?
Yeah,
Oh, too bad. So now we see the pattern. So in fact, if you have some probability, the probability of not getting in times the probability of not getting in is the probability of not getting in to both of them. And similarly, the probability of not getting in the power of x is equal to the probability of n x, or however many schools you want. So we'll construct these probabilities in math methods, but this is fun because you can just like see how likely it is to get into grad school. So let's say that the probability that you don't get into grad school is this number. So what's the probability that you don't get into 2 grad schools? Yeah.
What's the piece of like more advanced stuff?
But it's more, how do you use it more generally? So StatMech is very limited because you're forced to think about atoms and physical objects like this. And I will show you all of the applications that are possible. Okay, really quickly here, because this went a little too long. So let's say 2 schools. What do I put here? Probability they don't get into 2 schools. Good. So that's interesting, right? Because I could say like this. Well, hold on. I want to think about this in the context of there's a 90% chance that I don't get into both schools, but I don't really care about that. I want to know whether or not I get in, right? So let's write that again backwards over here. Let's do 1 minus that number. Okay. And I'll just do this number as 95. 0.9. Right? If I apply to 2 grad schools, my probability goes from 5% to 9.7%. Oh, so that's why I apply to more than one thing. Okay, let's try it again. How many schools do I want to go to? 5. Okay, and what do you think that's going to bring your odds to? 15? All right, you're doing better than you thought. Now you're up to almost 2 coin flips. Because remember, 2 coin flips is 25%. Okay. So this is how you would construct something, right? That was, whether or not you would go to grad school with a pretty reasonable 0.5. Okay. Now let's do something that you really care about, like winning the lottery. And we're going to start with an easier one. Let's win a raffle. Okay. So how many tickets do you need to buy to win a raffle? Well, let's change the probability first. Let's go back here. We're going to do 1 minus, and this will be the probability of the raffle. So let's say there's 100 people in the raffle. So it's 1 over 1,000. Everyone buys 10 tickets or something like that, right? What's the probability that you have a winning raffle ticket? Okay. How many tickets do you buy? What? 2. Okay. So you now have a 0.1% chance of winning. 0.1% chance of winning with 2 tickets. Now, let's change that number to the one that I told you about. Okay. Let's make this not 1,000, but 1,000,000. Okay. Let's see if there's enough zeros. 1, 2, 3. Okay. 1 in 1,000,000. Those are generous odds for the lottery. And let's say you buy 2 tickets. That's 1 times 10 to the minus 6. So how many tickets do you need to buy to start winning the lottery at these odds? A couple, right? Now notice that that is in the square there, right? So this is going to be times itself. So you're going to benefit a little bit, right? Want to see 5? That still looks like 10 to the minus 6 to me. You want to put 1,000. Okay, so there's a healthy man. I'm going to go 100 first. Okay. And now look at that number. Okay, that's at least 1, 2, 3, 4, 5 decimal places. And now we're at 10 to the minus 5. Hey, yo. Okay, so let's try some more. Okay, that's 10,000 tickets. Look at how good my odds are. There's 100,000 tickets. 100,000 tickets, you're now at 9% chance of winning the lottery. And what does 100,000 tickets cost? $200,000 at a 9% chance, which is worse than your odds of getting into 2 grad schools. Does this make sense? No, because if I flip a coin for you right now, I give you a coin, right? And I put a gun to your head, and I tell you, that coin needs to flip heads or tails. Do you let me? No, you do not. You could die. 50-50 is basically a coin flip.
You said that one needs to flip heads or tails. That's boring.
No, I say you have to pick one, right? And then if you lose, okay, let me specify the terms and conditions. We're gonna play a roulette game. Okay, we put one bullet in, and then you spin the revolver and you clock it closed. 1/6, right? That's slightly better odds than this. Do you play the game? Your life. I gotta win something. No, but do we see the point of these statistics here? Right? This is putting it into the correct context. Right? Yes or no? Do you play? Do you play? Do you play? Do you play? This one? You play this sometimes? Do you play this game? Okay. Do you play? The Russian roulette that I'm just offering you now.
Oh.
Okay, what if it's $100,000? But you might die.
1 in 6.
1 in 6 chance that you'll either die or win the lottery. $1 million? Okay, all right, that's good. Now you're getting a little crazy on me. Okay, so here's the thing, right? We can actually turn this into a plot. And the nice thing is that you could put a little exponential here. And you could say 4y equals 0 to 1 and x equals 0 or 1e9. Good. So that's how you would find out how many tickets you need to buy in order to start getting close to for sure. Now, once you're here, that's pretty good odds, right? But you have now bought 10 to the 6 tickets, which is something like 4 million tickets to be guaranteed that you will win one and win $1 million.
So why did
Which-
not just play?
Which is more money, buying every ticket or like if I bought every single ticket?
Okay, so now we're really getting into the economics, right? Because here's the question, okay? This is not even the right number. Let's look up the lottery number. Okay, the probability is something like 280 million. Okay, so let's look up lotto odds. Okay. Okay, so this one's now where's the actual California lottery? They have to post these. Here we go. They have these. Yeah. Yeah, this is how I made this TikTok in the first place. Okay. California lottery. And then here's the odds. So which one do we want? We want the Powerball, right? That's 435 million. And down here, the very bottom, game odds. Good. Okay, so here's the number. That's easy, right? It's only 292 million. So let's put that right in here. Oops, I should have got rid of the commas. You see down this? Do you see down there? Okay, let's go out another decimal place. Oh, shit. All right, let's go out another decimal place. And now let me ask you about the economics. So this number is not even, there's one. Let's say that that's one. Let's be generous. That's 1 billion tickets at $2 a piece. Is $2 billion to win how much money? Where is it? Where was it? Oh yeah, 435 million. So if you had $2 billion, this would be a poor investment. So I always tell people exactly the same thing. Okay, you can't win if you don't play, but your odds of winning never substantially increase past the first game. Now, is this something that you should do? No. Is it fun? Yes. Will you win? No. Right? I can almost guarantee no one in this room will ever win the lottery. But this is the idea, right? So how we understand statistics is a fundamental concern to how we live our day-to-day life. And my hope is that in math methods, we'll discuss how to properly assess and truly think about whether things are probable or improbable, likely or unlikely to happen in our lifetimes. Make sense? So that really got away from me. Because that is not what I wanted to talk about today. And thanks for coming on the trip with me. So let's talk about our class, which is what we're supposed to be doing. Let's get out the rubric again. And let's get your literature reviews out. Right? Everyone has their literature review. And you wrote your name on it. And you're going to hand it to your friend. And they're going to make notes on it. And if you run out of literature review, you can ask someone else for theirs. Right? Not everyone will be as thorough or complete. If you're looking at something that is just an outline, you can ask them for more details or workshop it. But I'm not going to require you to sit here. So my point is that I want to leverage this time to maximize your writing. Okay. That's not really writing. What do you mean? That's